Hello, Advanced Geometry students! Today's lesson is 1.1c. We're going to finish up section 1.1, which is the building blocks of geometry. And today's focus is on midpoints and segment bisectors. So you guys are pretty smart, and I imagine if you read this word midpoint, you could probably figure out what it means, right? Mid, middle, point, point. So middle point. It's the point that's in the middle of the segment. But because we don't really know what middle means in regards to geometric definition, we're going to define this using terms that we've already defined. And we're going to use it define it by using congruent segments. So a midpoint of a segment is any point that divides a segment into two congruent segments. So what I mean by that, here's my example, and it says, hey, in the diagram below, M is the midpoint of segment AB. Well, the definition of midpoint says that M then would cut segment AB into two congruent segments. So that would make segment AM congruent to segment MB. Booyah. All right, next order of business. It says, and remember, if there's no segment mark, no line, no ray, this means length or distance. So if the length of segment MB is 12 inches, put a little 12 inches right here. Then find the length of AB. I want to find the length of segment AB. You guys are pretty smart. You can probably figure out pretty quick what the answer is. But let's just work through what the definitions say in the deduction process here. So here's what I know. I know M is the midpoint, which makes these two segments congruent. And I know congruent segments have equal lengths. So if MB is 12 inches, AM must also be 12 inches. And then, if I want to find AB, it's simply 12 plus 12, which gives me 24 inches. Easy as that. Next vocabulary word is a segment bisector. A segment bisector is any line, segment, ray, or plane that intersects a segment at its midpoint. Again, if you break this word up, it makes a lot of sense. Bisector. You know, that word sounds a lot like dissect in science. Dissect means to cut, but it's not dissect, it's bisect, and bi is two. So bisect means to cut something into two congruent parts. So a segment bisector can be a line, a segment, a ray, or a plane that cuts through a segment at its midpoint, essentially cutting it in half or into two congruent parts. So we're going to use that to mark the picture based on what's given here. So it says, mark the diagram, then fill in the blank. We know that plane P, so here's plane P, bisects segment AB. When it says that it bisects a segment, it means it cuts it at its midpoint. All right? At its midpoint, which makes C a midpoint. And if C is a midpoint, that means it cuts this segment into two congruent segments, AC and CB. So I know, based on all those definitions of a segment bisector and a midpoint, that segment AC would have to be congruent to segment CB. And I marked my diagram to demonstrate that. Problem 2 asks you to draw a diagram that demonstrates this. So it says ray QR bisects segment ST. So QR is doing the bisecting. It's doing the cutting. And segment ST is being bisected, or it's being cut. So what I'm going to do is I'm going to start by drawing segment. Kind of cheat there, my fancy board here. Segment ST. And if ray QR bisects it, that means that ray QR intersects the segment at its midpoint. So I'm going to put a little midpoint there. I'm going to mark that these segments are congruent. And I know that ray QR has to go from this midpoint. So if I draw ray QR right here, the end point is Q. There's ray QR. And what this drawing demonstrates is ray QR bisecting segment ST because it is cutting it at its midpoint and cutting it into two congruent parts. So that's it. The words themselves should make sense, you know, sound familiar to other words and they're pretty obvious, midpoint and bisect, but just get used to the terminology and what it means. All right, so the next thing we're going to talk about today is how we can apply this to algebra. All right, so you guys plotted points in algebra class. So we're going to kind of combine these ideas with algebra. So we will do a lot of algebra applications with geometric concepts in this class. Because we can plot points on a coordinate plane and create line segments between those points, we can easily find the midpoint of a segment on the coordinate planes. Check it out. Here's how we would do that. I want to find the coordinates of the midpoint of segment AB. Here's segment AB. So let's just think, how do I go from A to B? Well, I go over 1, 2, 3, 4, 5, 6. So I went right 6, and then I go down 1, 2, 3, 4. Down 4. Well, if to go all the way from A to B, I go right 6 and down 4. To get to the midpoint, I'm just going to do half of that. I'm going to go right 3 and then down 2. So from A, if I go right 3 and down 2, I find, boom, here is the midpoint. And the coordinate of that point is 1, 3. Find the coordinates, 1, 3. Now let's talk about what I did so we can come up with kind of a rule. If I know going from A to B is a move of 6, and I only want to go halfway there, I did a move of 3. And if I know from A to B is a vertical move of 4, I want to go halfway there, I only did a vertical move of 2. You'll notice that this point is directly between these two. And any sort of number that's directly between two other numbers, we call that number the average. So you'll notice that all you got to do to find this point, you don't have to draw anything, you don't have to plot it. All you got to do is average the coordinates. Average means to add, or in this case, since there's 2 of them, you'll add and divide by 2. Negative 2 plus 4 is 2, divided by 2 is 1. 5 plus 1 is 6, divided by 2 is 3. So all you got to do to find the midpoint is simply average the x and y coordinates. All right, let's just do a couple examples without drawing pictures. So here's what that says. There's a little formula for this called the midpoint formula. Essentially, if you have any 2 points, x1, y1, and x2, y2, if you want to find the midpoint, you average the coordinates, which means I'm going to add the x coordinates together. I'm going to divide by 2. And I'm going to add the y coordinates together. I'm going to divide by 2. That's it. All right, so let's do an example. Find the midpoint of the segment whose endpoints are -5, 7, and 12, -1. I want to find the midpoint. To find the midpoint, I'm going to average the coordinates. So all I got to do is take my x coordinates, which is -5 and 12, add them together, divide by 2. Take my y coordinates, which are 7 and -1, add them together, divide by 2. So -5 plus 12 is 7. So I get 7 divided by 2. And 7 plus -1 is 6. So I get 6 divided by 2. Now, you guys, I am a big fan of fractions. Fractions are easier to do math with, in my opinion. I would like for you to be comfortable with fractions. While an answer of 3.5 for this x coordinate is appropriate and it will work, there's nothing wrong with telling me 7/2. And 6 divided by 2, of course, is 3, so we can do that. So while I'll accept 3.5, 7/2 is adequate. Okay? And the reason for just getting used to dealing with fractions is suppose you ended up with a fraction that's like 1/3. Well, you know what? You can't tell me 0.3 because 1/3 is 0.3 repeating. So in this case, a decimal approximation isn't helpful. So get used to fractions. All right, this time, this is really going to melt your face with fractions. Find the midpoint of a segment whose endpoints are at 1/2, -3, and -3/4, 3/2. So I'm just going to follow the same rules, okay? Maybe I'll do my x's. Well, yeah, let's just follow the rules. Here we go. So I'm going to do 1/2 plus -3/4. So I'm just adding the x coordinates together. And I'm going to divide it by 2, comma. Now I'm going to add my y coordinates together, which is -3 plus 3/2 divided by 2. Now, one thing, guys, when you're dealing with fractions, it is really helpful to make everything a fraction. So this -3, I'm just going to change it to a fraction as -3/1. Now, in order to simplify this, I first need to solve for the numerators. So I'm just going to take this over here and do a little bit of work. I want to add 1/2 plus -3/4. But in order to add fractions, I need common denominators. So I got to find a common denominator. And what I'm going to do is I'm going to multiply the top and the bottom of this one by 2 to make it 2/4. So 2/4 plus negative 3/4 gives me negative 1/4. So when I added those fractions together, I got negative 1/4 over 2. Comma. And we'll do this work over here. This is negative 3 over 1 plus 3/2. I'm going to get a common denominator, which I'm going to multiply the top and the bottom of this guy by 2, giving me negative 6/2 plus 3/2, which is equal. Negative 6 plus 3 is negative 3/2. So this is negative 3/2 divided by 2. Now the last thing, you guys, is when you're dividing a fraction by a number, there's a rule your teacher probably taught you. And instead of dividing by a fraction, you multiply by its reciprocal. Or your teacher maybe taught you something like keep, change, flip, or some sort of weird way for you to remember how to divide by fractions. But what I'm saying is, instead of doing negative 1/4 divided by 2, which is what a fraction means to do, to divide, I'm going to do negative 1/4 times 1/2. So instead of dividing by 2, I will multiply by its reciprocal. And remember, a reciprocal is where you take a fraction and you flip it upside down. So negative 1/4 times 1/2 is negative 1/8. And this time, instead of dividing by 2, so negative 3/2 divided by 2 over 1. No, I don't want to divide by 2. Rather, what I'm going to do is I'm going to multiply by its reciprocal, which is 1/2, which gives me negative 3/4. There we have it. Same process, you just got to do a little bit of work with fractions. And the last example here is working backwards. So you have some segment and one endpoint is at negative 4.7. Just going to draw like a little sketch of what this might look like. The midpoint is at 5, 4.5. What is the coordinate of the other endpoint? Well, I don't know this, and if I don't know it, I'm just going to call it x, y. Variables, I don't know. So what I need to do is, in order to find a midpoint, I average the x and y coordinates. So what that means to me is if I were going to solve for the midpoint of this, I would add the x's together, so negative 4 plus x divided by 2, divided by 2. So negative 4 plus x divided by 2 will be your x coordinate of the midpoint, and 7 plus y divided by 2 will be the y coordinate of your midpoint. Now check this out. X coordinate of my midpoint is 5, so this needs to equal 5. The y coordinate of my midpoint is 4.5, so this needs to equal 4.5. So I know, just do a little work, that negative 4 plus x divided by 2 must equal 5. And I know over here that 7 plus y divided by 2 must equal 4.5. And now I will solve for x over here. So I'll multiply both sides by 2, give me negative 4 plus x is equal to 10. I'll add 4 to both sides, so x is 14. So over here, I know that my x coordinate is 14. Now to solve for y, I'll multiply both sides by 2, so 7 plus y is equal to 9. I'll subtract 7 from both sides, so y is equal to 2. So the y coordinate is 2. So to answer this question, what is the coordinate of the other endpoint? It is 14, 2. And quickly you can check yourself by averaging them, the endpoints. 14 plus negative 4 is 10, divided by 2 is 5. Boom. And 2 plus 7 is 9, divided by 2 is 4.5. It all checks out. All right, that's it for today. Midpoints and segment bisectors. Good luck with your assignment. Let me know if you need anything.